All right, let's talk about a couple logarithm properties. In this video, we want to take a look at the product and at the quotient property of logarithms. The product property of logarithms is if I have a log of a product, in other words, two things that are being multiplied together, I can make it two separate logs that are being added together. Okay, if I have a product that I'm taking the log of, it can be a log, two separate logs, of those things separated but being added together. Quotient property, much the same way. If I have a division or a quotient, a division of two things that I'm taking the log of, I can make it a subtraction of two individual logs. All right. One thing to note with any of these properties, they work in either direction. Okay. I can either use this to expand or to condense. All right, what I am working with, and different things will, or different times will call for different things wanting to be done. All right, they work in either direction. Let's take a look at expanding first. If we start with log base 3 of 5x, we can simply make that into a log base 3 of 5 plus a log base 3 of x. All right. If we are dealing with log base 4 of 6y, we can change that into a log base 4 of 6 plus a log base 4 of y. We can take that a step further if we wanted to, make that into a log base 4 of 2 plus a log base 4 of 3 plus a log base 4 of y. Now, if we wanted to get really interesting, or really adventurous, I guess, we could look at this as a log base 4 of 4 to the 1/2 power. Okay, now, right now, we're not sure what to do with that. Okay, but in our next video, we'll talk about some exponent properties, and we will find that this 1/2 we can work with, and this log base 4 of 4 is then something that's very useful to us. But for now, we're going to have to leave it at that. If we look at log base 5 of 2/3, we can change that into a log base 5 of 2 minus a log base 5 of 3. Now for a more interesting one. What if we have multiple things going on? Well, there's more than one way to do them, but we can take them one step at a time and look at them, splitting them up. Because multiplication is commutative and associative, and division is just multiplying by the reciprocal, and that's where a lot of these properties will stem from. We can look at these things in a variety of different ways. But for this, I'm going to keep my divisions, my multiplications much on the same level. Here I'm going to take a log base 2 of 3x and split it into a log base 2 of 3 plus a log base 2 of x. And I'm going to subtract from that this whole mess, because I'm subtracting the whole log of 7y. And that's going to give me a log base, there should have been a 2 there, log base 2 of 7 plus a log base 2 of y. Now, we see that it's a plus because these two things were getting multiplied together. All right, so we see why it's a plus. But now as we go on from there, we can see that this subtraction sign needs to get distributed to both pieces. So we have one thing left to do, and that is to write this as the log base 2 of 3 log base 2 of x minus a log base 2 of 7 and minus now a log base 2 of y. That would be our fully expanded version of this particular logarithm. Condensing will work much the same way, just in the opposite. Okay, if we have a subtraction, that means it could be a logarithm of a single fraction, 5 over x. Okay. If we have three things getting added or subtracted together, we can just take them one at a time here. We can make this into a log base 2 of 12, multiply the 3 and the 4 together, minus a log base 2 of 6. Now we can take that a step further. We can make that into a log base 2 of 12 over 6, also known as a log base 2 of 2. And that we have to take one step further, because remember what a logarithm is. It's saying, hey, this 2 raised to what power gives me a 2? Well, this is one that we should be able to simplify, correct? We should be able to look at that and say, hey, a a log base 2 of 2 is simply a 1. Okay, log base 2 of 2 is simply a 1. And you might find that happen while condensing or while expanding. You might get some 1s to show up, maybe not for the whole thing, but for parts of it. Our last example, you can see, is similar to the last example that we had for expanding, but now we're trying to put it back together. My suggestion, honestly, with this would be to kind of recognize that all of your subtractions can be grouped together and all of your additions can be grouped together, and kind of go from there. So we can make this into a log base 4 of 2 and a log base 4 of y. Pull out a negative as a common factor. Now this one we really just put parentheses around, and that's about all we did, but we can now look at it as a log base 4 of a 5x minus a log base 4 of 2y. And you can see why pulling out this negative as a common factor to get this to be one particular thing was quite useful to us, because now we can take and make this into a log base 4 of 5x over 2y. If you don't do it this way and pull out this negative, it gets to be a little bit clunky. It gets to be a little bit interesting. I end up seeing things from people like, for instance, they'll end up with a log base 4 of 5x over 2 over y. And really, that's not that far off. The truth of the matter is, if you think about that, you take your 5x over 2 and you multiply it by the reciprocal, and you end up with a log base 4 of 5x over 2y. That's an x up on top there. And you can see that we have the same thing. I hope this is helpful as you go forward. And my best approach is to get all of your subtractions as divisions. They'll just end up in the denominator. All of my additions will end up in the numerator. Anything with positive in the front will end up in the numerator. Anything that's negative in front will end up in the denominator. And you'll see perhaps maybe as you look at the exponent rule in the next video how that actually goes along with what you already know. What you already know about exponents and negative exponents and what they do. Once again, I hope this is helpful.